Okay, welcome ladies and gentlemen to this video lecture. Let's take a look at this example. So we have a function f of x which is defined as 3x plus 1 divided by x squared plus 1, and we want to show that the limit as x tends to 2 of f of x is 7 over 5. Okay, so let's leave for you as an exercise to write out exactly what you need to prove. So write out the definition of the limit and writing out your proof outline. So I would suggest pause the video here and write out your the statement that you have to prove and your proof outline, and see if you get what I get. Okay, let's take a look at the statement that we need to prove. So we need to prove for every epsilon there exists a delta, so that if 0 is less than the absolute value of x minus 2 is less than delta, then f of x minus 7 over 5 in absolute value should be less than epsilon. Let's take a look at our proof outline. For every epsilon, so we fix any epsilon, we must show that there exists a delta. So we must define it. What are we allowed to use in defining our delta? We're only allowed to use epsilon. We want to show this implication. If x minus 2 in absolute value is greater than 0 but less than delta, so we assume that, and we want to finally conclude that f of x minus 7 over 5 in absolute value is less than epsilon. Okay, so let's fill out our proof outline. So here I've copied our proof outline. So we start off with this expression. This expression, f of x minus 7 over 5. Expand what f is, and we factorize and we simplify. And as an exercise, you can see, you can try this, we will get the following. Okay, so perhaps pause the video, see if you can get from here to here. Good. Now, let's see what we have to work with. We have control over things like x minus 2, because we assume this expression to be less than delta. Here we see an x minus 2. So we automatically get absolute value of x minus 2 over here is less than delta. So here we've got 7x minus 1 times delta over 5 times x squared plus 1. Okay. Let's think about this thing. I'm going to write it like so. So I'm just splitting these fractions, splitting this product, x squared plus 1. This thing we know something about. We know x squared is greater than 0. So x squared plus 1 is greater than or equal to 1. We're just adding 1 on both sides here. And we know x squared is greater or equal to 0, so if we add a 1, it is going to be positive, so this is the same as absolute value. So the absolute value is greater than or equal to 1. But if we divide both sides, this thing is definitely positive. It's strictly positive. It is bigger than or equal to 1. If we divide both sides, we end up with 1 is greater than or equal to x squared plus 1. So this thing over here is less than or equal to 1. So we can get rid of that. So I'm going to erase this, and I'm going to write here, put this in brackets, since that thing is less than or equal to 1, we get that. Let's write it this way, 1 over 5, 7x minus 1 times delta. Okay, and we're getting closer. We want to get rid of that thing. Let us think about how we can get rid of that expression. So 7x minus 1. Let me insert another page here. Oops. Okay. So we are interested in getting this expression less than 1. And we've seen before, how do we bound something like this by a constant? So we want to get that thing less than or equal to a constant. What do? We restrict our view to an interval around the point that we are interested in. So we are interested in the limit as x goes to 2. So let's write it down here. I'm going to say a. We claim that if x minus 2 is less than 1, less than or equal to 1, then 7x minus 1 is less than or equal to something. I'm going to leave that blank for the moment, and I'm going to show you a different method how to do this. So previously we started off with this thing, and we started manipulating that thing into the expression that we want. Let's do a different way. So let's take a look at, or let's start with our assumption. We assume x minus 2 is less than or equal to 1. Take your 7x minus 1. Let's take out this 7. I don't like it. So 7x minus 1 over 7. We have control, or we know something about x minus 2. So let's add and subtract. So we want minus 2 plus 2, 1 over 7. We haven't changed anything. We're just adding 0. Let us apply the triangle inequality. 7 times x minus 2 plus 2 minus 1 over 7. And here we see this thing is, by our assumption, is less than or equal to 1. So this thing is 7 times 1 plus and 2. Well, let's write it this way. In fact, what can we do? Let's apply the triangle inequality again. So this is the same as 2 plus minus 1 over 7. And minus 1 over 7 is less than 1. So this thing is less than or equal to 7. 1 plus 2 plus 1. That is 4. And that is 28. Okay. So the point here is there are many ways of finding a constant bound to this expression, and it doesn't need to be the best possible bound. In fact, this 28 is larger than it needs to be, but all that we need is to have it to have a condition, this condition under which this expression is bounded by a constant. And in fact, any number, once we've got this condition, any number bigger than 28 will also do. Okay, so we can go back here. And under this condition, if x minus 2 is less than 1, less than or equal to 1 in absolute value. So here we have to bake in a 1 into our delta. Then delta is less than or equal to 1. Then by a below, what do we have? Let's write it this way. Since x minus 2 is less than delta, which is less than or equal to 1, by a below, we've got 7x minus 1 is less than or equal to 28. So this thing is, let's put it like so, here we justify that step. This thing is less than that. And now we see immediately how we should bake in our or what we should bake into our delta. We want to bake in a 5/28 epsilon in there, and we choose the minimum. Then delta is also less than or equal to 5/28 epsilon. So here we've got 1/5/28 5/28 epsilon. 28 cancels, the 5's cancel, this is equal to epsilon. And we conclude that if 0 is less than absolute value of x minus 2 is less than delta, then f of x minus 7/5 is less than epsilon. And that finishes our proof. Okay. So there are two difficult steps in here. Firstly, noticing here 1/x squared plus 1 is always less than or equal to 1. That is a little exercise for you. And we showed by a different method that we used previously. We used here the triangle inequality to find a bound for this expression under this condition that this expression is less than or equal to 1. So we must force this condition to happen. That's why we bake in this 1 into our delta. Since we bake this 1 into our delta, we get here, and from here, since we've got a constant times delta, we can see how we should define our delta. To get rid of these constants, we also need to bake in 5/epsilon into our delta there. Okay, so this was a little bit more difficult. Okay, I will see you in the next one.